So our objective today is to understand and be able to write an indirect proof. Understand and be able to write an indirect proof. This comes out of lesson 6-3, and if my memory serves me correctly, this will be it for the quiz. So just the first 3 lessons. So Tuesday we do a review, Wednesday we'll take the quiz. Okay. So here's the good news. Because it's an indirect proof, it's shorter. And what we're doing is we're going to use the art of contradiction to be able to draw our conclusion for our proof. Okay? Sometimes we prove things directly, like in our 2-column proofs. We start with a statement and we come up with reasons and we build till we get to the final conclusion they want us to come up with. With an indirect proof, we take the conclusion and we negate it. We take its inverse. And then we're going to try to prove, more like a paragraph proof, and we're going to come up with a contradiction. As soon as we come up with a contradiction, we know that the original statement is false, or our inverse, is false, therefore the original has to be true. So it is a lot shorter, but it does kind of involve in the middle bit a little bit of the paragraph proof. All right, so let me give you a definition. And the definition is kind of long because there are three components to an indirect proof. So we want to address all of them in our definition. So an indirect proof. First, so this is one statement, and then you're going to skip lines, or you're going to number this, and then you're going to start a new place. So you're going to actually see 1, 2, 3 in these proofs. Okay? 1, assume temporarily. You're going to actually use those words. So I'm going to underline that. Assume temporarily that the desired, I'm having a hard time. Here we go. I can spell today. The desired conclusion is not true. So in other words, this is the inverse of the conclusion. The inverse of what to prove. Okay? So that's the first, single statement, starting with assume temporarily. Second, you're going to do a paragraph proof. So not 2 columns. Until a contradiction of the hypothesis. I'm going to underline that guy. Oh, contradiction, that's an interesting word. Contradiction. Wow! Brain, my gosh. Squeaky voice and a bad brain. What a great combination today. Until a contradiction of the hypothesis or other fact is reached. And you will literally, in the end of that paragraph says this contradicts the given or this contradicts this fact. You're going to use at the very end, but this contradicts. Okay, so I'm going to add that in there at the end. Okay. The third part, now you're going to start like this. Since the, and then in here you would put the temporary assumption. Since the temporary assumption is false, it must be true and then you would list in here the original conclusion. So again, we're trying to prove the inverse is true, but when we come up with a contradiction by logically equivalent, we can say that the original conclusion has to be true. Okay, so let's go out and do this and make sure that this makes sense. So I'm going to give you two. One's a little vague because it's just mainly built on words. The next one we'll do is more like what we're seeing in our proofs. All right, just for me, not for you. Thanks, Drake. All right, that was Drake Plotkin, by the way. Now you're famous in the video. Okay, so we're going to do a proof. And we're going to be given that n is an integer. And n squared is even. Our job is to prove that n is even. So the given is assumed to be true. So those are facts that we're going to be using. And we're going to be having them help us find a contradiction. What we're going to take is our to prove, and we're going to take its inverse. So here's step one. Assume temporarily. It's like we have temporary insanity. Assume temporarily that n is odd. Okay, so we're doing the inverse to the conclusion, the to prove part. So if you wrote this as an if-then statement, it would be if n is an integer and n squared is even, then n is even. Okay, so we're taking the then part and we're taking its inverse. Okay, so let's put in some logic. All right, let's think about it. Okay, so we have n is odd. Since n is odd, n squared would be equal to n times n. Now, according to this, if n is odd, I have an odd number times an odd number. So think about, what do we get when we multiply an odd times an odd? Yeah, do we ever get an even? No. So we get an answer that's odd. So we end up with this, that n squared would be an odd number. Wait a second. We're saying in the beginning, the given says n is an integer and n squared is even. That contradicts the given information. So we say this contradicts and then you can say specifically that n squared is even. So you could say it. You can add This contradicts the given that n squared is even. Okay? You got to put the contradiction as the last sentence in part 3. Therefore, hence, whatever, since n is, oh, you know what? I did something wrong. Hold on. Hold on a second. Let me go back. What I shouldn't, this isn't a negation. That was me putting in different words. I apologize. So n is not even, is the negation. And then because it's not even, the only other possibility is it's odd. So in the middle, so in part 2, I have to assume it's odd because it's not even. Those are my only two choices. So I apologize for that. So since n is not even is false, it must be true that n is even. Okay, so it sounds like you're repeating yourself, but again, all we're doing is rephrasing our conclusion. Since we know that this has to be false because we proved a contradiction, that n is not even is false, it must be true that n is even. So a couple things just to point out. This phrase, actually all three of those, usually show up the first three words in the second part. For some reason, sometimes I use the word since in the beginning of the second one, but not always. But then I'm going to be using this. This contradicts, and then this has to lead back to part of either a fact or the given information. And then this, therefore, since this goes back to your temporary assumption, is false, it must be true that this piece here goes back to what it should have been. So what I'm underlining is what I would see in everybody's. Now again, I apologize, this is kind of like teaching power writing where everybody writes the same exact way, but they may include different details. Okay, so it's a way to get you learning how to write paragraphs and then write 3 paragraphs and so on and so forth. So we're going to do this very prescriptive. So assume temporarily that, and then you take the opposite of what we're trying to prove, so the inverse of it. And then you go into your proof, and the last sentence of the second part says, this contradicts that, whatever it was that you're contradicting, from either the given or from a fact that you know to be true. Therefore, since, and then you put in your temporary assumption, is false, it must be true that, and you go back to what the actual conclusion is supposed to be. Okay? Very prescriptive. Very prescriptive. All right, let's do one more, but let's do it more like a normal proof. So this one says, given, we have a trapezoid PQRS with bases PQ and SR. So just to get you a quick little diagram, PQRS. What we're trying to prove is that the length of PQ is not equal to the length of SR. Okay? So, step 1 begins with assume temporarily. And what are we going to temporarily assume? Okay, so assume temporarily that the length of PQ is actually equal to the length of SR. Okay, next. Now we're trying to find a reason to contradict this given information. So the given information is that we have a trapezoid, and we're told which two sides are the bases. So we're either going to contradict something we know about trapezoids or their bases. Okay? So what do you think we could use to help on this one? What are some things that we could deal with if we're temporarily assuming that the length of PQ and the length of SR are the same. Michael?
You can prove that it's a parallelogram, and then
Okay, how? How could you prove that we end up with a parallelogram with this temporary assumption?
because if the bases are parallel,
Okay.
and opposite sides are parallel and congruent,
Okay.
then you have a parallelogram.
Okay, perfect. So basically, I know from a trapezoid that SR and PQ have to be parallel. From the temporary assumption, I've just said they're the same length. We have a theorem that says in a quadrilateral, if one set of opposite sides are both parallel and congruent, then you have a parallelogram. Well, we're told we have a trapezoid, which can't possibly be a parallelogram. So there's our contradiction from the what is a trapezoid. Okay, so let's see if we can write this out in a interesting way. So let's take that. And because I have PQ equal to SR, I'm just going to say that the lines are parallel from PQ to SR. So segment PQ is parallel to segment SR by the definition of a trapezoid. And then since PQ is equal to SR, they would be both parallel and congruent to each other. And therefore, would be a parallelogram. Now, I apologize. I'm probably the worst run-on sentence writer ever. Okay, so as long as I have my commas in, I should be good. And then, and then, and then. And here comes the contradiction. This contradicts, oops. The given information that PQRS is a trapezoid which has only one pair of parallel sides. Okay. So, I may have written more than I need to, but I just wanted to point out if I have a parallelogram, I have two sets of opposite sides that are parallel. When I have a trapezoid, I only have exactly one pair of opposite sides that are parallel. So that's kind of where the contradiction comes into. You may say, can I stop at this contradicts the given information that PQRS is a trapezoid? And I would say probably that would be sufficient, because by definition we know it only has one set of parallel sides. Aiden.
We get marked out if we put more information.
Only if it's more information that's not pertinent to your proof, yes. If it's information pertinent to your proof, no. Okay.
So if I stated like SP is parallel to RQ, that's definition of parallelogram, that might be marked out.
No, that would support that you would have both sets of opposite sides are parallel, which we know can't match with the definition of a trapezoid. Georgie.
So, in the second step, you have to prove that it's contradicting?
That's the whole point.
Okay.
That's why the last sentence has to include the phrase, this contradicts.
And then in the third step, then you're telling me why that has to be. So basically...
So the third is just actually a summary.
Oh, so the point of this proof is to prove that the proven part is...
By contradiction, prove that it's true.
Okay.
So we're going to prove its opposite is false. Therefore, logically speaking, the truth is the truth.
Okay.
Okay? All right? So here's our last one. Therefore, since our temporary assumption, PQ equals SR, is false, it must be true that PQ cannot be equal to SR. And that's how we would conclude it.